All right. Good day everywhere you are, morning, afternoon, and evening. You're actually welcome to today's workshop. Yeah, it is actually application of GIS in agriculture, and specifically today, we are going to be taking somewhat a cue, but in a different way. From yesterday. Yesterday was basically another exciting training with the use of Google Earth Engine for cropland mapping. You know, such a fantastic application in the field of agriculture, and I hope you enjoyed yourself and you got a lot of value yesterday. So today we are dealing with, to me, a kind of a more interesting topic, and with a more and also our facilitator today, our training, our lecturer today, is also somebody I have also checked his profile, his works, and I just like his disposition, and I'm very sure that you would also enjoy it today. So today we're going to be dealing on UAV, so that's drones. UAV means Unmanned Aerial Vehicles application in the field of agriculture. So you've been hearing a lot about drones in agriculture, and precision agriculture particularly. So the applications of UAVs in precision agriculture. So that's what we're going to be doing today. By the way, my name is Femi Adekoya, and you can call me the Flying Farmer. And in relation to that, and that's because I use drones in agriculture, and I use drones to help farmers collect, verify actionable data, and provide insights that empowers them to do precision agriculture. Without further ado, and what we have been waiting for, so I will just be introducing our speaker today, and a lecturer. So to the stage to train us on the use of UAV, or the applications of UAV for precision agriculture. So join me, welcome Dr. Ahmed Rabia. He's actually an assistant professor and at Damanhour University, in Egypt. So, Doctor, you're welcome. Thank you very much.
Thank you, Femi, for the introduction. Hello, everyone. Thank you for having me today. I really admire what you're doing, guys. And I'm very happy that I'm contributing to your mission and objectives today through doing this training. So thank you for what you are doing to the agriculture youth. So my name is Ahmed Rabia. I'm from Egypt. I am assistant professor at Faculty of Agriculture, Damanhour University in Egypt. And I will start immediately the presentation so we can. Okay, let me. All right, so you can see the screen now. Okay, perfect.
Yes, so, the screen is on. Yes.
Thank you. So before I start, there is you can see the bull, I think. There's one question just to understand the audience, if you already have experience with UAVs or not. So if you please, you can participate in the bull during the introduction, and then when it's finished, I think Joshua, you can show us the results, please. So I will just a very small introduction about myself. I did my master in Egypt in soil and water science, and then I went to Italy. I did another master in remote sensing and GIS, I did my PhD again in Italy in remote sensing and GIS, and I had the opportunity to have 3 postdocs, 1 in Italy and 2 in the US, 1 in the University of Georgia, and the last one here in Texas Tech University. Generally, I'm interested in, of course, in precision agriculture, in soil science, land use and land cover change, and I did a lot of research about this. The environmental studies, climate change, and of course, machine learning, introducing machine learning into the agriculture sector. I love traveling, so I traveled to many countries during the previous years, mostly in Europe during my PhD. So you can see the stars already, mostly in the middle part. Today we were going to work to speak about the applications of UAV or unmanned aerial vehicles in the sector of precision agriculture. So the contents will be I will introduce the UAVs, and then we'll speak about what types of UAVs are available in the market, how we can classify UAVs or one of the classification types, the examples of UAVs, what are the general applications, and then what are the sensors that can be mounted on the drone, on the UAV, and finally the applications inside the agriculture sector, or specifically in precision agriculture. I will show some case studies, 2 case studies that we have done using UAV images. And finally, at the end, we will have the opportunity to do actual hands-on dealing with image coming from UAV, doing the pre-processing before doing any remote sensing or any GIS work, how we take the photos from the UAV and actually generate real image from the field. So this will be hands-on training. Joshua, I hope that we can show now the ball. If everyone is already, so I think, yeah, it's 100% should be everyone. So now you can see the ball, right? Yeah, okay, so we can see that mostly most of the participants doesn't have real experience working with UAVs, and this is good because this is what the presentation or the training is directed to. Okay. So I know this is should be like a lecture or something, but I like to be to do active learning more than just lecturing. So if any one of the participants who did already the ball and said he doesn't know anything about UAVs or just know general information about UAV, can you show tell me what you think the UAV means, or what is the drone means? I think
it's better to use the chat.
Yeah, the chat, yes.
Okay.
Yeah. So if anyone can anyone? No one? Okay, so let's go with it. Takes your pick. So we have David. He says that it's basically a taxi or vehicle used to carry sensors. Okay, so it's close to the definition we're going to show. So a drone or a UAV, both are the same, is actually a flying robot. So if you see a robot before that, just a robot with wings, so it can fly because it can be remotely controlled through ground fly pilot or through the software on board. And of course, the drone itself has the global positioning system, sensors on board. just to use it to capture the image. So the UAV market is growing very fast during the last decade. So if you can see here, in the last 7 years, it's just growing very fast up until this year, growing from 0.6 billion, so it's like $500 million, and now it's 5 billion, and it's expected to be 12 billion during the next 2 or 3 years. So it's growing very fast. That's why everyone is moving to the drone industry, because it's easier, faster, and you get very precise results. And if you see the different industries using the drones, you can see that agriculture is the second big industry using drones for to work with. Of course, the infrastructure is one of the biggest ones, and then agriculture is dealing with almost 32 billion for using drones. Unfortunately, Africa is not following rapidly. If you can see here, mostly all the work is North Africa, Europe, Asia. They are dealing with drones or working with drones very big, but in Africa it's growing very slow, and even the prediction is still not very much. And we can imagine that there is some restrictions, of course, to grow this industry, but we can try to improve this in the next few years. So we have different types of drones. Of course, there is the small drones, the toys. You can buy it just to play with at home or in the park, and it can cost you starting from $25 to $100. Of course, the flight time is very small. It's like 5 minutes to 10 minutes. You cannot mount any sensors because it's flying barely with its weight. And of course, you can use it just to recreational, just to take some pictures or videos for yourself and or for the park or for your house, something like this. And then we have the professional drones or professional UAVs, and this is the expensive one, starting from 1,500 to 1,500. 15,000. This is bigger drones. It can fly longer. It can fly from 18 minutes up to 35 and sometimes more. It depends on the weight, the load, the sensors you mount on. Of course, it can hold bigger payload, so you can mount bigger sensors, more sensors. You can even add some tanks to put fertilizers or irrigation water. So that's why the application for this professional drones goes from photography to mapping, surveying, data gathering, and fertilization, irrigation, and package delivery, inspections. So there is many applications for this specific drone type. And finally, of course, the big deal, the big drones. This is the expensive ones, are 1 million or plus million price, and it can carry a very high big load, starting from 250 kilograms. And of course, it's used for surveillance and weapon delivery and something like this. So, but we're not going to speak about this today, of course. The drones can be classified by different classification methods. So you can classify the drone based on the altitude they can fly, based on the weight, based on the payload. But one of the very common classification is based on the shape of the drone. So if you can see here from left, we have the fixed wing. So in this case, the drone has like it looks like an airplane, has fixed wing, just one or two motors at the back, and it fly like a normal airplane. And this is one of the very common drones used for the big areas like like if you are going to do a survey on a forest or a big environmental study. So in this case, you will need a fixed wing drone because it fly longer time and it can fly easily for a bigger scale fields. Then you have starting the helicopter, the tricopter, where the helicopter, of course, has one motor. The tricopter has 3 motors. Y6 copter has 3 motors with 6 rotors. And of course, the common one is a quadcopter. This is a common shape of the drones or UAVs with 4 motors. The hexacopter with 6 motors. Also, this one is common in agriculture sector. The octacopter with 8 motors, and here octa V is 8 motors, but with a shape of V. So the very common UAVs shapes is a fixed wing, the quadcopter, and the hexacopter. This is the common in agriculture sector. So if you have a bigger field, you will use the fixed wing. If you have smaller fields, it will be better to use the quadcopter or hexacopter because it will be easier to manipulate during the flight. So it can turn faster, it can go for a smaller scale field. In the fixed wing, the drone has to take the turn for a longer area, so it will take longer time, and this will cost you time and money, of course, because you will have to fly again to cover the small, very small area. So it's better to use a quadcopter or hexacopter in smaller areas, fixed wings in bigger areas. So we have, of course, here some general examples for the use of UAVs or drones. It's not only in agriculture, of course. So you can use the UAV for a training. So, for example, here's firefighters are doing a training, and you can showcase during the training with the drone, showing the other participants how to deal with the problem. Inspection, of course, if you need to do a fast inspection and in a bigger scale, you can fly the drone and see the whole building in a very fast way. You can see a real-time view from your building. And of course, utility inspections. So in this case, if there is a very high altitude utility, you can just fly the drone without, you don't need to make someone go up and check the problem. You can just fly the drone and check if the problem in this tower, for example. You can then you can send someone to fix the problem. If not, you can go to the other tower, check the problem, and see what you need to fix, and then you can get the tools and the parts, for example, and then send someone to fix it. The commercial real estate. So, of course, if you want to, for example, sell a big commercial real estate, you can use the drones to show the area of the state, the real estate, show the person who's interested how it looks from aerial view, something like this. Construction management. During the construction of a building, you can follow up with the construction during the time, so you can see how the construction is going during this time. And of course, the environmental applications like site survey. You can do faster site survey in inaccessible areas or bigger areas, so it will be faster to do through the drone. And also environmental monitoring. You can use the drone to monitor the environmental problem, especially in inaccessible areas. If there is a place you cannot access easily or you cannot go easily, so the drone will help you to deal with this problem, of course. The fancy applications like real estate showcase, like this, for example, and also in mining. In mining, they use the drone to develop a 3D model for the mine, and then in this way they can calculate, for example, the excavation amount or how much did they excavate during the last month, or they can produce an estimation of the excavation during for this mine, for example. And recently, Amazon started delivering the package using drones. It's a very new application, and it's very interesting now. And many other countries are many other companies are trying to follow up in this application. And I think it will be very interesting in the next few years. It will grow rapidly because it's faster and easier to deliver packages. They are still in the processing how to deliver exactly the package and how to drop the package, something like this. But it's already working now. Some of the cities in the US, they are already using the drones for delivery. So the drone itself is just a platform. You need to mount something on this platform. So the drone itself is just a way to go up in the sky and see the field in different way. But you need to mount on the drone some sensors, so you can use the camera. You can use the sensor to capture images for this field or for this application, to use it later to do the analysis. So we have different applications. We have different sensors. We have visual sensors where there is the camera is like a real camera, RGB camera. We have the multispectral sensors. We have thermal sensors, hyperspectral, and finally the LiDAR sensor. So as I told you, the visual sensor is a normal camera with normal spectral bands, like the camera in your phone, for example. It's a RGB camera. It's called RGB camera, and we can use it to capture real images from the field. We can use it for mapping or for taking images for photography, for plant counting, for example. Emergency response and surveying. There is many applications using the RGB camera, but the limitation in this case that you have only 3 bands, the blue, green, and red bands. So in this case, you cannot calculate many indexes based on these 3 bands. That's why in this case, we go to the multispectral sensor. The multispectral sensor has more bands, mostly 5 in most cases. You have the normal 3 bands, the blue, green, red, and then you have near infrared band, and then the rate age band. So in these 5 bands, you can use these 5 bands to do more application, to do more analysis, develop or calculate more indices, to use it for the analysis. That's why we can use these sensors for plant health management, for water quality assessment, for vegetation, creating vegetation indices, and of course for plant counting, also for like the RGB, but in this case, you will use different indices or different calculations. Then we have recently, well, not very recently, of course, but recently the thermal sensors, they have been introduced to the agriculture sector. So many researchers starting using the thermal sensor to do some applications in the precision agriculture. The thermal sensor is different from the RGB or the multispectral because it's targeting the heat of the object. So if you are dealing with agriculture fields, so the heat of the plants or the heat of the soil temperature. If you are dealing with for example, ranch, so the temperature of the cattle, the temperature of the animals, you can use it for animal counting, for example. You can use the temperature based on the camera. You can use it for animal counting, for the livestock management or detection. Of course, in our case, we use it for water temperature or soil temperature analysis. We use it for water studies in this case. And then finally, the emergency response. For example, if there is a fire or if there is someone stuck in a building, you can use the thermal sensor to find where exactly this person is based on the temperature of his body. Then we have the hyperspectral sensor. The hyperspectral sensor is similar to the multispectral sensor, but with more bands, more channels. So you have more, you have higher ability to deal with land. You have different bands, so you can generate more indices, or you can calculate more indices based on these bands. Not only 5, it's much more. And then you can use these bands to calculate the indices. And of course, you have you can deal with more sophisticated problems in the field related to the plant health, so water quality, the vegetation indices calculation, even the soil mineral or soil health. So in this case, you can use it for more developed analysis. Finally, the LiDAR sensor, it's also a recent sensor introduced to the agriculture sector, and it deals with, it's mainly used for 3D construction of, or 3D models constructions. So we use it normally to construct a 3D of the object. So in our case, if in agriculture, we can construct a 3D of the field. So this way you can have an idea about the height, the plant height, the plant distribution in the field. If you're dealing with forests or big trees, you can have a very nice view, 3D view of your study area, showing the height of the different trees, the amount, the area of the tree. So, for example, if you can calculate the yield for the tree based on the area from the 3D model. And it's used recently in the field of agriculture, especially for the for the long crops like maize or similar, like sorghum, something like this, because it's dealing with height. So that's why it's more effective in taller crops. So using the UAV, we can deal with different crop features, starting from in the vegetation part of the crop, or even in the soil. So in the soil, of course, you can capture some information like soil temperature, like water content or the moisture content in the soil, electric conductivity. So these some of the features you can capture from the soil, and other features you can capture for the crop or for the vegetation part of the crop, like a biomass, like a nitrogen status, the moisture content inside the plant cells, vegetation color, the chlorophyll content inside the leaves, the spatial position of the plants. For example, if you are dealing with trees, you can get the spatial position for each tree in the field, the size and shape of the different elements of in the field. So as I told you, you can get the area of the tree, the shape of the tree, if it's bigger or smaller, and then you can use this information to deal with the field or do the management in the field. Of course, you can. This is what you can capture using the area is a UAV image, but you need to deal with vegetation indices. Vegetation indices, if you're not familiar with what is vegetation indices, so this is how we can say it's you can calculate some indices using the image to measure some features in the crop or in the leaves or in the soil. And using these vegetation indices, you can get more information, more than the raw image or more than the normal image. So what we were saying before this was a general application of the UAVs, but now we can speak more specific about the applications inside the agriculture field or inside the precision agriculture field. So, for example, of course, one of the top applications for UAVs in agriculture, precision agriculture, is plant health monitoring. So, in this case, during the season, you can monitor your crop, the health of your crop. If there is a problem, you can see it faster, and you can see it more specific, with more precision. You can see where exactly is the problem, and then you can act based on this information. Of course, like I said, we can calculate different vegetation indices, but one of the very famous indices is NDVI. This is the first index you will calculate, because this is it gives you an indication based on the health of the crop. So if you are growing your crop during the season, you can understand how is going the health, if it's getting some, for example, the water is not enough in the field. If there is a problem in the, like a pest problem or disease problem in the field, you will see immediately the effect based on the NDVI image. So if you see here, for example, we have the healthy plant will show a specific signature, like in the near infrared or the red, green, blue. The healthy plant will show specific signature based on the absorption or the reflectance of these plants. The stressed plant will show different signatures, so you can see. Of course, the dead leaf will show totally different signature. So you can differentiate between the healthy plant and the stressed plant, dead plant, and then you can show the farmer, for example, a map of his field showing how much exactly is effect in his field, where exactly to deal with this problem. So, for example, here in this part of the field, it's 100%. It means that these plants are healthy, and you don't need to change anything. Your management is good in this part of the field. But for example, in this part of the field, 15%. So it means that you need to deal with this problem. There is a problem in the irrigation. There is a problem in the soil. There is a problem in like a disease or pest in the soil, in the plant. So you show the farmer where exactly to deal. So in this case, if the farmer is going, for example, if there is a problem in the fertilization, for example, nitrogen fertilization, the farmer doesn't need to fertilize the whole field based on this, based on the information. No, he is going to exactly go to the specific spot of his field and then fertilize this spot. And this way you will eliminate a lot of costs for the farmer. You will reduce the working times, machine cost, fertilizer cost. So in this case, using the UAV, you will reduce a lot of costs for the farmers. And of course, it will be faster. Another application is monitoring the field. So you have a big view for the field. If you are growing a small field, it's easier for you to go every day to check the field. But if you are growing like a 100 hectare or 1,000 hectare, it's not easy to go every day and check the field and check the development of the crop in the field. So in this case, you will using the drone, it would be faster to have a general view of the field, monitor the whole field, and know what is the problem or where is the problem. the irrigation, if there is an irrigation problem. For example, if there is a problem for one of the drippers, one of the sprinklers, it will show immediately in the map, and then it will be faster for you to go and deal with this problem. So, of course, if for the small farmers, it's not a very big deal because they can see the whole field in 10 minutes or 1 hour at maximum. But for bigger fields, it's a problem. So using the drone will help very much for to deal with the bigger fields. Recently, the UAVs have been used for planting or seeding. Of course, it's more used for afforestation. For example, if there's a place where they need to grow a forest in this area, it's easier for them to fly the drone and drop the seeds everywhere in the field, and then the trees will grow up in this area. So if it's an accessible area, of course, the drones will be much easier to deal with this problem. You don't need to send your workers in an inaccessible area or dangerous areas to spread the seeds. So in this case, using the drones will be faster, easier, and more efficient, of course, to use. Also, like I said, when if you have a problem in the field, you can use the drone for fertilization or pesticide spraying, fungicide spraying. So in this case, the drone will have a tank that you can load the fertilizer or the pesticide in the tank, and then you can load the map for the fertilization or for the spraying. As I said, you don't need to do just one amount for the whole field. You can have a map loaded to the drone, and then you can just spray specific amounts for different parts of the field. So in this case, you will reduce the amount of fertilizers, you will reduce the amount of pesticide, you will save money, you will save time, you will keep the environment safe. Of course, if you reduce the amount of chemicals sprayed in the field. So it's very interesting application in precision agriculture for the farmers, because you can fly the drone. Of course, the field will not be very big. It's for bigger fields, you will have to fly the drone several times. For smaller fields, you can cover the drone. You can cover the field with one flight, for example, but you will be able to control the exact amount of fertilizer or of pesticide in each part of the field. Recently, the researchers are also trying to introduce more applications of drones or UAVs in the field of precision ag or agriculture in general. So one of the recent application is pollination. So in some crops or some trees, the farmer needs to do pollination management to the field. So he needs to do the pollination to the crop to get the yield, of course, to increase his yield. So using the drones, it will be easier, of course, if you're dealing with long trees or bigger fields. Excuse me. Using drones will help the farmer to do the pollination management faster and more efficient. And it's work in progress, of course, but it's giving very interesting results recently. And I saw one of the application in the palm trees in the Saudi Arabia, and it's very interesting application. So it's faster, easier. You don't need the worker to climb the tree to make the pollination by himself. You just fly the drone and do the pollination tree by tree. Well, one of the applications, of course, is also using the drones for irrigation. It's not, in my opinion, it's not very efficient because the drones the flight time is not very long, so we need to fly several times to cover the field. But still, as I mentioned before, you will be able to control exact amount for each part of the field. So if you have a variable irrigation amount in your field, so if you have a field with different soil types or different growth rate for the plant, using the drone will help you to apply different amount of water in different part of the field. So you will save water, you will save time, you will save money. In some cases, the farmer will pay for the amount of water he's using. In some areas, maybe in Africa, it's not very big deal. In some countries, the water is available, so to the farmers, they can use the water whatever they want. But in some areas, the water is very important. The water is very scarce, so you need to be very specific with the amount of water you're using. So in this case, if you have a variable rate of irrigation, you can use the drone to apply this variable rate based on the map you're going to load to your drone, and then you can apply different amount of water in the different part of the field. One of the very recent applications, and it's still under research, is using the drones for harvesting. So the researchers are trying to develop a drone that can harvest the crop. So for example, the citrus trees or the orchard trees, the drone can fly close to the tree and start picking the crop, picking the fruits from the tree. Based on the sensors, you can even control how mature the fruit, and then you can choose to pick this fruit or not based on the sensor, based on the maturity of the crop of the fruit. But still, of course, this is under study, and it's very at the beginning of the research, so it's not used as a commercial application yet. So this was an introduction about the UAVs. And this now I'm going to show two case studies. We use UAVs image to deal with some problems in the field, in the agricultural field, of course. The first case study, we were using the UAV image to do plant counting. So after you plant your field, sometimes you have a problem with seeds, or sometimes we have a problem in the soil. So not all the seeds will grow to a full plant. So you will need to replant these spots with new seeds. But if you have a bigger field, you will have to go through the field and check where exactly are the missing spots, and try to make a map to show the planter where exactly to drop the new seeds. Using the UAV image, we could use the image to show exactly how much stand the plant stand in the field, and where exactly the spots are missing, and then you can give this map to the planter, and it will be faster and, of course, more efficient. So the objective of this study was to assess the application of two deep learning models, the MobileNet and CenterNet, in counting the cotton plants in the field using the UAV images. So as you can see, we used the quadcopter UAV to take some images to the field at the beginning of the planting, after 10 days and 15 days. So after the growing of the plant, so you have like 3 to 4 leaves for each plant, and it's very small plant. At this stage, you will be able to replace the missing spots, and you will have a homogeneous crop in the field. If you are too much late, you will have smaller plants and bigger plants, and this way the irrigation and fertilization will be different in this case, and it will make a problem for the harvesting or for the crop itself. So we had two different dates. The first date was after 10 days. The second date was after 15 days. We have two different flights. We flew the drone at 20 meters height, and then we take this image to the processing under the deep learning models. We created different testing images, and then we used both the models to evaluate the results for counting the plants. And of course, we did the testing at the end to see how much of the plants have been detected by using this model. So here you can see the dates. We have two different dates. A and B is image from the first date. C and D, A and B from the first date. C and D is from the second date. And then you can see here, for example, this is two different plants. So this is two different plants, but the model recognizes the plants as one plant. Here you can see that there's two different plants, but still one of the models, the one on the left is a center net. So one of the models has recognized as one plant, one of the models recognized as two plants. In some cases, you have missing plants, but we will see it now. So it's not very like 100% accurate, but still work in progress. So you can see here, this is different results based on the number of images, number of the test image. So to train the model, to train the deep learning model, you need to introduce some image to the model to make the model learn. It's a deep learning. So the model will learn how to recognize the plants in the field. So if you, for example, in this case, we introduced 400 images, and here we introduced 900 images. So this is two models, the center net model, the mobile net model, and two different number of training images. So you can see, of course, one of the models was very efficient when you increase the amount of training image, was mostly increasing the accuracy for the capturing the plants. The other one, in some cases, increasing the number of training images reduced the accuracy, and it's very common in the deep learning. In some cases, if you increase the training number of training image, the accuracy will increase, and it will be better to see or to detect the object. In this case, one of the models was behaving abnormal. So in case of increasing the number of images, the accuracy dropped. So the other case study is also using the deep learning, but in this case, the UAV images have been used to detect the yield. So in this case, in the sorghum, it's panicles. The sorghum panicles is the yield of the plant. So again, the objective of this study was to use the deep learning models and UAV images to detect the yield of the crop, and then compare between the real image and the result from the deep learning model. So again, we use the quadcopter to fly. By the end of the season, before the harvesting, we flew the drone again at 20 meters height, and then we capture the image for the crop, for the whole crop, and we use this image to delineate the sorghum panicles, and then we train the model to only detect the panicles, only detect the small yield, the sorghum panicles. And based on this prediction, based on this detection, we can predict how much yield we have in the field. And also, so you can see here the model where we're able to detect different size of the crop. So here's this small bar is the actual yield. So here it's detected the medium size, the small size. In this case, the model were able to detect different size of the yield. However, still we have, in some cases, we have overestimation. So in this case, overestimation means that the model detected the sorghum barnacles in some areas where there is no yield, and underestimation where there is actual in the field where there is the sorghum barnacle, but the model didn't detect these barnacles. So here, for example, you can see the different overestimation, underestimation situations based on the different number of the training image. So we have 100 training images, 500 training images, and 1,000 training images. So when you increase the number of images, you can have less amount of overestimation, but in this case, you have more amount of overestimation. So underestimation will be less, but overestimation may increase. So you will have, maybe you will have more prediction for more yield. In this case, you will have higher yields than the actual one in the field. So you need to be very careful with using this model if you have to predict the actual yield in the field. But still, we had good results. So you can see this is the actual RGB image. So this is the actual barnacle here, 1 to 3, for example. And this is the training image. So we draw the image, we draw the barnacles on the image, and this is the prediction from the model. So it's almost like 90% or over 90% similar to the actual situation. So with this, I think I finished my introduction or my presentation, and then we're going now to the training, the hands-on training. We will use one of the softwares to deal with the UAV images. I hope that some of you have already installed the software, and we are going to show how to use the image inside the software. I think that they sent an email yesterday, or I think on the WhatsApp group, about downloading and installing the software, downloading the dataset, the image dataset, and how to even under the file. So we're going to use, okay, so I'm going to stop here, and then we go to the IGSoft software. So if any one of you has already installed the software, please try to follow up with me. And if there is a problem, you can just send me a message on the chat. I'm sorry, I was not following the questions, so I hope that by the end we can answer these questions if we have time. But for now, so this is the platform, one of the software that can be used to pre-process the image. So when you get the image from the software from the UAV, you have a huge amount of images, because the drone, while the drone flying on the field, is taking several images during the flight, and then you will need to stitch all these images together to make a one big image, or one big orthomosaic for the whole field. So you can use this image, or you can use this orthomosaic for further analysis, to do vegetation indices, to do mapping, to do surveying, whatever. But you have to do the pre-processing to stitch all the images. So this is what we're going to do. We have the raw data coming from the UAV, and then we will use these raw data to generate the ortho image, the orthomosaic for the field. So of course, I sent you a very small data set. It's just 50 images for the small portion of the field, because if I send the whole field, it will be like gigas, because it's each image is like 2 megas. So if you have, for example, one is this field, the one we are going to use, we have over 1,800 images for the field. So if we're going to use this whole field, it will take long time and for processing. So we're going to take a small subset for this field. So the first step is to import the image inside the software. So we have, of course, here the software. We can first save the project we're going to use. We can save the project, for example. You can save the project wherever you want. You can save it with any name you want. And then you can go to the workflow and then start to adding the image. So you will have from workflow, you have add photos. And then, oops, sorry. Here you can add all the images from the subset, and it will be loaded to the software. We have 2 different scenarios. If you are flying the drone with the RGB sensor, so you have the normal camera with 3 bands RGB. So in this case, you will use single cameras. So it means that you have 1 camera with 1 image for each spot on the field. That's why you can use a single camera. If you are using a multispectral sensor, so in this case, on the sensor, you have different cameras, you have different sensors, you have different bands. So in this case, you have, for the same spot in the field, you have different images. So for example, if you are using multispectral, you have 5 or 4 images for the same spot. So in this case, you will use the multi-camera system. So if you can check here, for example, the number of images is 204 if you are using a single camera scenario. But if you use the multispectral, the multi-camera scenarios, it's 51. So it's dropped to the number of the sensors. Then you press OK, and you have the different image for the whole field. So each closed spot here is 1 image for one spot in the field, and this is the whole field, or the whole subset of the field. So all these images are in the field, and then you have here each image. You can see each image, or each band for each image. And on the left here, you can see that you have 51 cameras or 51 images. So the next step, we're going to do an alignment to the image. So when the drone fly, it's not all the time exactly 90 degrees on the field. Sometimes there is wind. Sometimes the battery is not 100%. So sometimes there's the alignment for the camera is for the drone is not exactly. So that's why we need to do an alignment for all the images. So again, we'll go to the workflow, and then you will have here aligned photos. This would be the only option is active. The other option is not active because you need to do first the alignment before you develop any of the next steps. So the first step has to be aligning the photos. So if you press, you will have the small box here for aligning the photos. The accuracy is high. You can keep it high. If you have medium, you can keep it medium, or you can use the high accuracy. For generic pre-selection, you can, if this option is selected, please deselect this option, because in this case, for the agricultural fields, the area is bigger, so you don't need very high resolution for this step. Then you click OK. Then the software will start doing the process for the alignment. In this case, if the camera is not exactly 90% flying on the field, so the camera will be tilted so that the image will not be to the actual spot. So the software is trying to see if the spot is exactly in the field, in the right spot, or it's tilted. And that's how we're going to use this information later for the processing to do the stitching. Okay, so if someone is following, are you all at the same? You can write in the chat if you are at the same stage, or if you are back behind. Okay, I see that. Okay, good. So it will take like 1 minute or 2 minutes to do the processing, of course, based on the speed of your machine. If you are working on a slow computer, of the processor is not fast enough, this step will take longer time. Okay. Anyway, I have prepared for this, so we can just jump to the next step. So what I'm going to do, I will just open another project. Is after doing the alignment. So this is the same project, but after doing the alignment. If we wait for this process to finish, we will have this result. Okay, so this is the result after the alignment. So if you can see, each blue square is the image for the flight, one image from the flight, and this is the whole field. Okay, if you use the 3D model, you can see, for example, here, you can see this is for these bars showing the alignment for each image. So some of the image is not exactly 100% aligned on the photo, on the spot. So let me just zoom here. So you can see here, some are not exactly aligned, and this is what we're going to use later. We're going to use this information to do the stitching for all the images. So the next step is to do to build the dense cloud. So using this image, we build a dense cloud for all the image for all the field. Okay. Well, let me just remove this image before I show you here. So this is a very pre-processing shape for the field. So this is not very clear now, but you will see it later how it's going to be showing. But this is the different spots in the field from different images, and this all will be stitched together to show to make the orthomosaic later. So again, the next step will be building the dense cloud, and then again you will use the high quality to do the dense cloud, because this will give you a better resolution, a better quality for the final product. So then now you're building the dense cloud for the field, and then you will use this step for the next processing to build the DEM or the DM for the field. Okay, I hope that everyone is following. Sorry, it's not. Yes, of course. If you don't need to use ultra high. Even you can use the medium to make it faster if you need to. You can just, this is just a demonstration, so you can use the medium or the low if it's going to make it faster for you to process the image. But in the real situation, if you're going to deal with the real image, it's better, of course, to have the high resolution or the high quality. You don't need the ultra high quality. In this case, ultra high quality is more important if you are going to do a 3D model for a statue or a building or something like this. You need a very high resolution for the image. But in the agriculture field, you can only use the high quality. Okay. So someone is asking up to some extent high. Yeah. Okay. So again, this step is going to take like 2 or 3 minutes. Of course, this is only because we have a very small subset for the field. If you are dealing with a real field or bigger field, it will take hours. So in this case, normally we start the software and we do the processing, and then we leave it to the next day until the software finishes the processing. Okay, so now we finished the dense cloud. Okay, and here you can see that we have the cameras aligned. The dense cloud is generated, the dye points is generated, and the dense cloud is generated. And the next step will be building the DEM, the digital elevation model. So we need to build the digital elevation model for the field to use it to do the orthomosaic. So of course you can do the next step, the build mesh, the tile model, but for the time now we don't need to do it right now. We'll jump to the building the digital elevation model for the field, and then we can do the orthomosaic. All right, so you can just leave the settings as it. We don't need to change anything in the setting, because you are using the same setting coming from the camera to building the digital elevation model. So we just use the building the model, and then you press OK, and it will start to doing the processing to build the generate the digital elevation model. This will take time, of course, but so again, I have okay. We have a pre-processed project. In this case, we can use the pre-processed project to show how will be the result after doing this. So after we finished the digital elevation model, before, okay, let's see. Before using the digital elevation model, you have here the model, and you have here the ortho tab, but it's blank. So there is nothing here in this tab. If you show it, there is nothing. But after generating the digital elevation model, if you tap here, you have already generated the elevation model for the field. So if you zoom in, you can see the actual view, of course, not the RGB. This is just the elevation model. So you can see, for example, the trees. You can see the house roof. You can see even some cases like a car or something. But this is not very clear now. after doing the orthomosaic, you will see the actual field. So again, we go to the workflow, we go to the next step. So we finish the building, the DM. Now we will build the orthomosaic. And again, we are not going to change any of the settings, leave the settings as it, just press OK, and it will do the processing. Are we running late?
Sorry.
Yeah. Okay. Yeah.
Are we running late? I'm sorry. Maybe it took more time than I planned to.
I think we're good. We're good. We're good. We're good.
Okay.
Okay. Yeah.
So anyway, this is the most important process, the most important step. So building the orthomosaic is the most important step, and the one that take more time, of course. So that's why, again, we're going to. You can wait for the processing, but I will just for the time. I will jump to the next step in another project, and to show what would be the result after doing this process. So after doing this process, we will have the orthomosaic, which is the final product in our case, the real image for the field, or in this case, of course, because it's a multispectral, it's not real image, it's just different bands for the field. But we can use this final product in another analysis. So let me bring this one. Again. Okay, orthomosaic. So this was the last step we had, but after the orthomosaic, you have here the DEM, and then you will have here the orthomosaic. If you double click this one, it will show you the final product. So this is the final product. Of course, the color is not real color because, as I said, this is a multispectral, so it's not going to give you a real view from the field. But you can see the houses, the trees, even the car here. You can see even the spotlights here in the car. So it's a good resolution for working in the agriculture field. And then we can use this product and go to another software, any software you're using. For example, in my case, I use ArcMap. You can do further analysis. You can use different bands to do a more sophisticated analysis. So just I will to show you, this is the small subset, and to show you how big the field is based on this subset. I will show you the full project for the whole field. So if you remember, last time when we were working on the small subset, we had only 50 or 51 cameras. In this case, we have much more bigger number of cameras. We have here 450 cameras, and this is only the 450 spots. For each spot, we have different bands, so you have different images. So this number is multiplied by 5 or 4. So again, if you go, so we were using only the small portion, this part of the field. We're using only this part of the field. This is the whole field, and this is the orthomosaic for the whole field. So you can see the different part of the field here. And then you can do some analysis here in the software. You can do some analysis, but of course it's not very clear like the other softwares, but you still can do some analysis here. Yeah, I wanted to show you the survey statistics, but it's better to show it in the smaller one because it will take time. So here in the tools, you can have the statistics for the processing, for your processing. If you press, it will generate a statistics report showing you an estimation or analysis for the flight, for the software, for the image, for the cameras, everything about the processing for this project. So if you can see here, this is showing the number of images for each spot. So for each spot, how many images cover this spot? So you have this is the number of images that covering each spot. So if you have blue color, it means that this spot is covered by different images from the UAV. If you have a lighter color, it means that because it's at the edge of the flight, of course, there is less amount of images, so there is less amount of coverage for each spot. The camera location, if you see here, the red spot, the red color means that the camera, the drone was not exactly 90 degrees on the field, so it was tilted. So it means that the camera is not taking the right shot. But if the circle is small, like here, for example, very small here, it means that the camera was in the right spot and it's very accurate in this part. Okay, so let's go. Where is? Let's go to the ArcMap. So this is the final product we had from the small subset. So we have different images. So each image is one band. So we have 4 bands, different bands for each image. And of course, we have the big field. So using this image or these bands, you can further do more analysis, generate different indices, gather different information about the field, and introduce more efficient management in your field. But so in this case, you can have a very precise, for example, information about each spot in the field. You can tell the farmer where exactly to add more water. For example, in this spot, there is a problem here. You can see that the color is different. Of course, there is, in some cases, there is a problem in for example, this dark color here. This is not in the field. This is from the camera. So you can eliminate this in the next processing step. But this part here, so this is a problem here in the field. You can see that there is a problem in the soil or in the crop here. So you can show the farmer where exactly the problem is and how to deal with it. Okay. So, okay, let me stop the sharing. Oops. Okay. So I'm not able to stop the sharing. So if you can just stop sharing. Okay. Sorry. Okay, so by this I finished my part of the training. I hope that you were following the last part with me in the real hands-on training, and I hope that you enjoyed the lecture or the seminar. And if you have any questions, of course, I'm here to answer.